Right, today we're going to talk a little bit about logarithms. So, logarithms undo exponentials. That's the intuition. In general, we'll write log base b of x equals k. And this is the same thing as writing that b to the k equals x. So one way of thinking about this is just another equation. This is a special way of writing this equation. We write it this way. But, as often is the case, we'll want to also be able to think of this as a function. So log base b of x will be the function which tells us what k is there such that b to the k equals x. All right, so for example, log base 2 of 8 equals 3 because, or equivalent to, like the 2 cubed is 2 times 2 times 2, which equals 8. All right, let's do 2 more examples. I'm going to write the 2 examples, and I'd like you to pause the video after I write down values and calculate them for yourself, and then we'll see if you got the same values. So the first one is log of base 1/3 of 81, and the other one is log 5 of root 5. Obviously, these are going to be a little trickier than that. So pause now, and okay. All right, hopefully you worked out answers for these. So let's see. So for the first one, we need to find a number k such that 1/3 to the k equals 81. That doesn't look obvious to me. What can we do? Well, 3 to the k equals 81. That's probably a little easier, right? 3 to the k equals 81. Well, we probably shouldn't call this k. We should maybe call this something else. I'll call this capital L. 3 to the L equals 81. Then L better be full. Right? 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay. So how can we get from here to here? Well, 3 to the negative 1 is 1/3. So 1/3 to the negative 4 will end up being 3 to the negative 1. So you would go 1/3 to the negative 1 to the 4. So the 4 equals 81. So log base 1/3 of 81 is negative 4. Okay. Now, we'll try to do something similar for log base 5 root 5. We need a number k such that 5 to the k equals root 5. And in this case, we'll just stare at it for a bit and remember that 5, it's taking the 1/2 power is the same as the square root. K equals 1/2. Okay. So those are basic examples. Oh no, maybe not so basic, but hopefully there's some degree of familiarity with something like this. Now, one of our key ideas here is going to be that logs undo exponentials and exponentials undo logs, right? They're inverse functions. Okay, it's a term we would have used last semester, so you can use that if you'd like. Log base b of x is an inverse function of the function b to the x, as long as b is fixed. And we have to be careful. We want b to generally be positive. If b is 0 or negative, we're going to have issues. Okay. Now, because they're inverse functions, because they undo each other, every rule, every algebraic property we had about exponentials is going to correspond to a corresponding algebraic property involving logarithms. Okay. Let's see what we mean by that. I'm going to erase. So one of our rules for exponentials, I'm going to rewrite it a little differently than we normally write it, but we had, because we're using b as our base, so I'm going to try to be consistent with that. So I'm going to write b to the m plus n. That's equal to b to the m times b to the n. What does that correspond to with logarithms? Well, let's see. We'll take log base b of both sides of this. This side, the inverse function, so this becomes m plus n equals log base b of b to the m times b to the n. That's not very nice looking yet. I'm going to rewrite b to the m and b to the n as different numbers. And I'm going to write b to the m equals x and b to the n equals y. Now I'm going to note that log base b of x equals m, log base b of y equals n. Again, these are inverse functions. So on this side, we get from here, this is log base b of x plus log base b of y. And that equals log base b x times y. So the log of a product is the sum of the logs. That's how we say that. All right, and that's one of our log rules. It's an important one. All right, the log of a product is the sum of the logs. Okay. Caution. Well, actually, I'll say the caution in a second. Caution. This is an important caution. There is no nice rule for log of x plus y. Okay? Students often want this to be like log x plus log y. No, logs are not linear. There's no easy way to simplify this, okay? It's true that the log of a product is the sum of the logs, right? We just saw that. And so I guess to be careful here, I should always have a b there to be clear what I mean. But it is not the case that this rule, that there's any nice way of writing this, okay? The other very basic log rule we have has to do with a log of a pattern. That is log base b x. Oh, I don't want to use x again. So let's use, we're using x as our variable up there. Let's use a to the t. Okay, equals t log base b of a. And you're encouraged to spend some time thinking about what exponent rule does this correspond to. Okay. Those are our most basic log rules, and we'll do a little bit more with them over the next few days also.